Hello people, welcome to Gurukula. This is Jay. So today in this video we are going to cover certain topics that is related to cellular architecture. So first of all, to start off with, we will be seeing the basic concepts and basic definitions of what are all the terms which will be involved or we will be coming across while studying the cellular architecture, and later on we will see the proper architecture of the mobile phones that we are using nowadays, that is your GSM architecture. So now let us get into the topic. So basically, when you consider the very fundamental architecture of a cellular system, it comprises of four components. The first one is mobile station, and the second one is base station, and third one is mobile switching center, and fourth one is public switched telephone network. So let us see what each and everything does one by one. So mobile station is nothing but that is our handheld device what we have in our hand. So that is what we refer to as mobile station, and which will be moving from one point to other point along with this. And the signals that is generated from the mobile station will be forwarded to the next component. We call it as base station. So base stations are nothing but those are all the fixed stations which you could see on ground. They will be mounted on the towers. You can see certain towers on the ground. So those parts are what we call it as base stations. So base stations are the fixed stations which is responsible for receiving the signals from the mobile station, and basically these fixed stations will actually contain the radio channels. The total available channel will be allocated here at the base station, and as well as this will have the transmitter and then the receivers which is mounted over a tower just to increase the heights of the transmitting antenna and then the receiving antennas. And all the signals that is collected from the base station is now forwarded to the next phase. We call it as mobile switching center, which is also abbreviated as MSC. So your MSC is responsible for coordinating in the routing of calls in a large service area. So actually I can call my friend can be located at any place on this geographical region. So my call has to be routed to that particular number. So MSC will take the responsibility of routing my calls from exactly to the intended receiver, and all the cells that is connected to all the signal that is connected to mobile switching center is now forwarded to public switched telephone network, that is also called as PSTN. So which is the world's collection of interconnected voice oriented public telephone network. So actually the PSTN comprises of all these switched telephone networks around the world. So that is a very basic architecture and very basic components that is involved in cellular architecture. And now we'll march forward and then we will see how this cellular architecture actually covers a particular geographical region. So here in this slide, the GSM architecture will cover a particular geographical area like this. So this is how the entire geographical region is further classified into a small regions, hexagonal shape regions. As you could see in the figure, the entire geographical region is classified into several small areas, and you could see that each and every small areas is served by a particular base stations, and you could see that the mobile stations are over here which moves in this particular geographical area, which can be considered as any vehicle or the people, those who are carrying the mobile phones with them. So this is what we call it as the base station, and this is what we call it as the mobile station, and this particular area is what we call it as cell. So actually a cell is technically defined as any geographical area that is covered by single base station is what we call it as a cell. So that is the reason why we actually call it as a cellular system. So this system will divide the bigger geographical region into small cells, and these cells will be served by a particular base station, and all the signals collected from all these base stations will be connected or it will be forwarded to an MSC, that is your mobile switching center, and your mobile switching center will in turn forward the calls to the PSTN, and where the call will be routed to the intended receiver on the other side. So that is how an GSM architecture is used to cover an geographical area. So actually what we have discussed so far will cover a very basic architecture and then a very basic intent of an GSM architecture, and there are several other components which is involved in the GSM architecture, which we will see. We will look a little bit deeper into the architectural perspective of GSM in the next slide. So the detailed view of GSM architecture can be represented like this. So these are all the various components which is present in the entire GSM architecture, and as you already know, this is MS stands for the mobile switch, this MS stands for the mobile stations which we actually have in our hand. And then it is not always possible for us to install one single base station which covers a very large geographical area. So in order to solve this problem, the large geographical areas or a cell which is further classified into small regions, we call it as sectors, or we call it as sectors, and each and every sector will be taken care of this BTS. So here BTS is nothing but that is base transceiver station, and which is an piece of equipment that actually facilitates the wireless communication between the user equipment and then the network. User equipment here is that is nothing but the mobile station what we see over here. So that is what actually we call it as BTS. So there will be several BTS which actually responsible for covering one particular cell, and the signals collected from every BTS will be combined and it will be forwarded to BSC. And your BSC is nothing but that is your base station controller, which actually receives signals from multiple BTS, and then it monitors very number of base stations and provide the interference between, it provides the interface between the cell sites and then the mobile switching center. So that is the main function of this BSC. And in next, you could see that all the signals collected from several base station controllers are connected to mobile switching centers, that is MSC. And over here in MSC, we have three different components, out of which the first one is HLR. Your HLR is nothing but, we abbreviate that as home location register, which is actually a database from a mobile network in which information from all the mobile subscribers is stored. So HLR usually contains information such as telephone number, or the identity of the user, and then associated services and some other general informations about the location of the subscriber. Subscriber is nothing but again the user over here. So all these kind of informations will be registered in the HLR. And then the second component connected to the MSC is VLR. So VLR is abbreviated as Visitor Location Register. So which is also a database which contains the exact location information of all mobile subscribers currently present in the service area. So this information is actually necessary to route a call. Without this information, I cannot identify where exactly the user is, and without this information, I cannot able to route the call to the intended user. So if my VLR will be helping the entire algorithm to trace out where exactly the receiver is, and thereby the routing will carry forward. And moreover, the next component that is connected to MSC is AUC. So here AUC stands for Authentication Center. So the main function of this authentication center is to authenticate or to validate the respective user. So whenever the user is allocated a particular channel to communicate, and it is the responsibility of AUC, that is Authentication Center, to keep the data transmitted by this MSC and BTS encrypted. So the security related perspectives will be taken care of this Authentication Center. So that is the primary function of this AUC, and together my MSC will coordinate with HLR, VLR, and as well as your AUC. And another thing which will be come across is OMC. We call it as Operation Maintenance Center, and which is actually used to monitor and to maintain the performance of each mobile station, base station, and as well as BSCs and MSCs. So this is like an overall supervisory section. So this actually supervises the functioning of all the previous components whatever we have discussed. It will supervise the MS, that is mobile station, base station, and as well as base station controllers and the mobile switching center as well. And finally, we have PSTN and as well as ISDN as well. PSTN is what we have already seen, that is public switch telephone network, which actually connects the entire world of wireless networks. And your ISDN is nothing but that is integrated services digital network, which is actually a communication standard. So which defines a standard to communicate voice, video, data and other network services in a traditional PSTN network. So we will be using PSTN network to transmit our voice, data and whatever be the type of data that I wanted to transmit, we will be transmitting over a common telephone network, that is PSTN network. So your ISDN defines a standard on how to communicate all these messages over a PSTN network. So this is a detailed insight of my GSM architecture. So now we will see something on the GSM channels. And to start off our discussion of the GSM channels, I will take the very basic components of the GSM architecture, and there are the 4 components, and we very well know that these two interfaces, that means the mobile station and the base station, is interfaced with an wireless access, and the rest of the part is an wired communication, and this rest of the part which is connected in wired communication is what we call it as backbone networks. And to be in wireless communication subject, I am very much interested to discuss, or I am very much interested to focus only on this particular section, because this is where only the wireless communication exists, and rest of the parts will be covered, the rest of the part will be connected by an wired communication. So when a mobile station is getting interfaced with the base station wirelessly, then there are certain standards which actually defines how this channel has to be, which interfaces the mobile station and then the base station, and that standard is specified by Common Air Interface, that is CAI standard. So what is CAI standard? Your CAI standards will say that the entire channel, so let us assume that this is the total channel bandwidth which is available at the base station. So this channel bandwidth has to be divided into 2 halves, whereas the first half is responsible for transmitting my voice and data, and then the second set of channel is responsible for exchanging the control informations. So the first set of channel is what we call it as voice and data channel, and the second set of channel is what we call it as control channel. And now furthermore, this voice and data channel is further classified into 2 halves, whereas the first one is what we call it as forward voice channel, and the second one is what we call it as reverse voice channel. And similarly, the control channel is also further classified into 2 halves, and then as forward control channel and then reverse control channel. So the necessity for dividing the channel into 4 halves like this is what each and every channel will carry the traffic from one direction to other direction, whereas my forward voice channel is responsible for transmitting the signals from base station to mobile station. So this channel, forward voice channel, is responsible for taking the information from base station to mobile station, and whereas similarly the reverse voice channel is responsible for taking information from mobile station to base station. So these 2 channels will act together so as to make my channel as a full duplex. So what do you mean by full duplex? Actually, I can able to transmit messages in both the directions simultaneously. So making the channel full duplex is possible only by combining 2 simplex channel, and here forward voice channel is like an 1 simplex channel which will carry signals only from base station to mobile station, and reverse voice channel is the again an simplex channel which will carry information only from mobile station to base station. So 2 simplex channel will be combined together so as to make my channel as an full duplex channel, and then the rest of these 2 channels will combinedly work in setting up the calls. So these channels are especially used for exchanging of control messages or control signals, which is responsible for establishing a call and to terminate a call. So that is all about the GSM channels. So next comes the channel access mechanisms. So how do I actually access this particular channel? And in real time scenarios, we know that a particular base station should able to serve many number of mobile stations which is located in that particular geographical area. So there are two primary questions which we have to answer, and our further discussions will primarily focus on answering these two questions. So in real-time scenario, a single base stations will have to serve several mobile stations simultaneously. So how is this even possible? And so there are two questions which has to be addressed. The first question is how full duplexing is achieved, which means we all know that the link that is existing between the base station and then the mobile station is a full duplex link. So how is that full duplexing link is achieved, and what is the technology or principle behind that achieving that full duplex link? So that is the very first question which I have to address. And the second question, we will try to see how these multiple users are sharing the channel bandwidth which is available with the base station. So these are all the two questions which we will be trying to address. So first of all, going with the first question, so how is full duplexing achieved? So full duplexing can be achieved by a technique called duplexing. And when we talk about duplexing, we have two types of duplexing. The first one is frequency division duplexing, which is abbreviated as FDD. And as per the concepts of frequency division duplexing, we can see that the forward channel and the reverse channel are separated. Over here, the reverse channel is a simplex channel and the forward channel is again a simplex channel, and where these two channels are separated with a frequency, which means I will be allocating a separate frequency to act as a reverse channel, and I will be allocating different set of frequency to act as a forward channel, and then so that these two channels will be separated with a frequency. So that is what we actually call it as frequency division duplexing. So one frequency is used to communicate in one direction and other frequency is required to communicate in opposite direction. So combining these two things will tend to appear like will make the link to appear like a full duplex channel. So this is one method of achieving full duplexing. And duplexing, there is one more type, that is what we call it as time division duplexing. So I can achieve full duplex by time division duplexing as well. So as per the concepts of time division duplexing, the forward channel and the reverse channel will be separated with respect to time, which means reverse channel and forward channel will use the same frequencies but at different time periods. So in time division duplexing, a duplex communication link where uplink is separated from downlink by the allocation of different time slots. Say for an example, a 5 MHz of bandwidth is allocated, and then this 5 MHz of bandwidth will be treated as uplink, that is forward channel, for a particular time slot, and again this 5 MHz of bandwidth will be again used by the reverse channel, that is my downlink channel, for the next time slot. So here the channel will be used as both forward channel and reverse channel, but with different with time. So that is what actually we call it as time division duplexing. And this is a conceptual representation of my frequency division duplexing, where you could see each and every channel is divided with respect to frequency. So I will allot blue represents the different frequency set and yellow represents the different frequency set, and then this actually represents the time division duplexing, where you could see the entire frequency is used for the forward channel over a particular period of time, and then the entire frequency is used as a reverse channel over a particular period of time, and then this forward and reverse will be happening on a cyclic fashion. So this concepts exactly depicts the time division duplexing, and this concepts exactly depicts what is frequency division duplexing. So that actually addresses our first question. So that is how we will be dividing the available channel into two halves. One can be named as forward channel and the second can be named as reverse channel. So this division of channels can be done by the concept of duplexing. So either I can use frequency division duplexing or time division duplexing to achieve the channel access mechanism. So now we will march forward and then we will try to address the second question: how actually the entire channel is being shared among multiple users. So how the mobile users share the available spectrum, and we already know that a particular base station has to serve multiple number of users with a limited or finite amount of spectrum. The limited amount of spectrum has to be shared among the multiple number of users. So there exactly the sharing concept comes into the picture. The basic resource for wireless communication is actually a radio spectrum, which has to be effectively utilized, which should not be wasted. So in order to achieve this, multiple access techniques comes into the picture. And many multiple access schemes are also available, which will allow many mobile users to share simultaneously a finite amount of radio spectrum. The sharing of spectrum is required to achieve high capacity by simultaneously allocating the available bandwidth or channel to multiple users. So by doing this multiple access technique, I can actually increase the capacity of the system. And then, as we already seen, the duplexing is also required so as to make the channel look like a full duplex channel. So obviously any of the duplexing technique will be used in combination with multiple access technique. And then it is also important to note that all these things, the multiple access has to be done without any significant degradation in the performance of the system. So it is actually a trade-off between the capacity and then the quality. So if I increase the number of users in a particular spectrum, that will actually degrade the quality of service which is provided for each and every single user. So multiple access technique has to be taken care of, and there should be an hard or soft limit where the number of users can be restricted so that without affecting the quality of service. And then there are quite a lot of multiple access technique available. They are frequency division multiple access, time division multiple access, spread spectrum access, and space division multiple access. And whereas the spread spectrum is further classified into frequency hopping multiple access, code division multiple access, and hybrid spectrum multiple access. And whereas in the further upcoming videos we will be studying detailed about FDMA, TDMA, and as well as the CDMA, since they are the widely used multiple access technique in a cellular environment. So just to summarize the today's video, so the things what we have seen in today's videos is we have seen the basic concepts and then the definitions of various terms that is involved in cellular architecture, and we have seen a basic architecture of an cellular system, and then we have seen an CAI standard for GSM channel, over which we have came to know that the channel is classified into forward and then reverse channels, and then the concepts of duplexing, which is actually used to make the link a full duplex link, and then the concepts of multiple access technique. It is also important to share the available channel with multiple users, which is actually possible by using the multiple access technique. So that is all about today's video. So the rest of the things will be covered, which means our next video will be covering the frequency division multiple access and several other multiple access technique. So until then, happy learning.